All right, so another week has gone by, and the class is cruising along. Things are getting a little bit more challenging, well, a good bit more challenging, week by week. The technical complexity of the assignments is increased. Um, I really wanted to do something interesting, and usually when it gets interesting, and fun, it also gets complicated. One of the things that the students in my classes here like to do, they like to make games. And one of the games that they commonly would like to make is a maze game where you've got a character that likes to run through a maze. But if you try to manually create a maze, it's very time consuming. And so a common question to ask is how can I get the computer to generate a maze for me? And of course it can. So I thought this assignment, we would write a computer program that just generates a maze randomly. And so where I started was I typed into Google, of course, maze generation algorithm. And an algorithm is a computer science word that describes a process for solving a problem. In this case, the problem of generating a maze. And of course, one of the first websites that comes up is Wikipedia, and we know that Wikipedia is a good source. So if I go to that, there's all this sophisticated, complicated reading that, I have a master's in computer science, and as I read it, I understood maybe, 50, 60% of what I was reading. But enough so that I kind of got the idea of how I might go about creating a maze. And what really helped was these videos. So I'm just going to play this video because this video is kind of the basis for the maze generation algorithm that I implemented. Although mine is a variation, it's different from this. And the idea is that you start with some point and you just build out, choosing random points that are adjacent to what you've already got. And if that point is valid, meaning that it doesn't close off the maze or create a loop somehow, then you go ahead and just nibble it out. And you keep doing that until you've gone as far as you can go. It's not exactly that simple, but you get the general idea. They give pseudocode, okay, so it's kind of in English, description of the algorithm. Start with a grid full of walls, pick a cell, mark it as part of the maze. Okay, so when they say mark it as part of the maze, I would say mark it as a passage because they'd use the word passage here. So nibble it out. Add the walls of the cell to the wall list. Okay, so that's probably poorly phrased. Add the neighboring walls. So you've just nibbled out a little cell. Add all the little cells that are next to it to a list. Now, while there are walls in the list, so this is a loop. So the list is not empty. Keep going through this loop over and over until the list is empty. So as long as there are walls in this list, pick one at random. And if the cell on the opposite side isn't in the maze yet, isn't already a passage, do this. Otherwise, remove that wall from the list and then pick another one at random. Okay? So if it isn't in the maze yet, make it a passage and mark the cell on the other side as part of the maze. Okay, I'm not entirely sure about the marking the cell on the opposite side as part of the maze, but okay. And then add the neighboring walls of the cell to the wall list. And so you add all of the elements adjacent to the thing that you just created to the list. Now, my algorithm varies a little bit because I found that checking a cell on the opposite side not being a part of the maze Well, I had trouble figuring out what was on the opposite side because I didn't know which direction I had gone when I picked one at random from the list. So I did a variation of this. And, they have lots of maze generation algorithms, so, it's fine to do a variation as long as it creates a maze. And a maze is something where if you pick any 2 points that are in the maze, there is exactly one path between those 2 points, okay? If there's more than one path, if there's a loop somewhere, then it's not a valid maze. So let's see if I'm just going to go ahead and go through a new implementation step by step and try to explain as I go what I'm doing. I'll go kind of fast, and feel free to pause. When I first implemented this, it took me 6 or 8 hours. But now I'm going to go really fast for you, and hopefully it's not going to take, it's definitely not going to take that long the second time around. And hopefully, since you get to just copy a lot of my code, it won't take you quite so long either. All right, I'm going to pause this video and then start a new video where I demonstrate the creation of the maze program.